We constantly guess what the future will look like, but we rarely ask how it will be funded. Let's run the numbers. What if atmospheric carbon removal becomes a highly profitable commodity market? If pulling carbon from the atmosphere shifts from a state-funded regulatory cost to a commercial gold mine, the global economy faces an entirely new set of complex resource allocation problems and distribution incentives. Modern environmental policy discussions often assume that creating a commercial price on carbon extraction will automatically stimulate a highly competitive, dynamic, and efficient marketplace filled with numerous innovative technology startups. This optimistic view ignores the physical and capital-intensive reality of industrial gas extraction, which behaves very differently from typical digital technology platforms, consumer software markets, or simple retail services. When a service is both globally essential and requires immense physical infrastructure, the competitive ideals of classical economic theory quickly break down under the weight of massive entry barriers. Rather than a competitive swarm of small local operators, a commercially viable carbon extraction industry would likely consolidate into a highly centralized, powerful, and deeply entrenched global corporate cartel. To understand this market structure, we must examine the physical reality of building industrial facilities designed to filter billions of metric tons of carbon dioxide directly from the ambient air. Unlike digital companies, carbon extraction requires immense land areas, massive physical-chemical processing plants, specialized synthetic filters, and direct connection to dedicated clean energy infrastructure grids and supply lines. These massive infrastructure requirements translate into astronomical upfront fixed capital costs that only a small number of well-capitalized multinational corporations and sovereign wealth funds can afford to finance. Interestingly, the massive scale of initial investment required creates a natural bottleneck that shuts out smaller players before they can even begin to purchase necessary chemical and mechanical engineering equipment. A new competitor cannot start small and scale up organically. They must build gigaton-scale installations immediately to achieve the operational efficiency required to make any commercial profits at all. Consequently, the first firms that deploy this capital will enjoy an unassailable capacity lead, granting them significant price-setting power over the global carbon credit markets for decades to come. Let us define the unique economic equilibrium that emerges when upfront fixed capital costs are exceptionally high while the marginal cost of ongoing operations is extremely low in comparison. In economic theory, this cost profile represents a natural monopoly, where a single large firm can serve the entire market more efficiently than multiple competing businesses or municipal utilities. It comes down to scarcity. The scarce resource is not the carbon itself, but the massive, highly specialized industrial capacity needed to filter, transport, and permanently sequester it deep underground. Because the atmosphere is a global common resource, any carbon removed benefits everyone, creating a classic free rider problem where private buyers lack individual economic incentives to fund the cleanup. This non-excludable characteristic means that government intervention through mandates, subsidies, or direct procurement is absolutely required to fund, manage, and sustain the carbon removal industry over the long term. If state agencies guarantee high purchase prices or minimum quotas to attract private investors, they effectively create a guaranteed artificial demand for this essential, survival-oriented global commodity service. This state-backed demand, combined with high capital barriers, creates a perfect environment for anti-competitive consolidation and coordinated pricing among the dominant carbon removal operators in the private market. The private corporations that build the first functional gigaton-scale extraction plants will capture the market, establishing an enduring monopoly over this critical atmospheric recovery service for the entire planet. Under this assumption, these dominant market leaders will face strong incentives to form a cartel structure to coordinate their extraction volumes and global credit pricing to maximize cooperative wealth. By coordinating their operations, these firms can prevent oversupply in carbon credits, keeping the market price artificially high to maximize their long-term corporate profit margins and investor returns. If they engaged in aggressive price competition, they would rapidly erode the returns required to amortize their massive initial capital investments and infrastructure construction loans from global banks. Therefore, the most rational economic move for these major operators is collusive cooperation rather than the competitive price wars described in standard, simplified textbook market theories of supply and demand. Under this assumption, they will partition the global atmospheric capacity into distinct spheres of influence, mirroring the behavior of historical oil, gas, and electricity resource cartels of the past. The resulting corporate cartel would effectively regulate the supply of carbon credits, deciding how quickly the atmosphere is cleaned and at what global financial cost to governments and consumers. This concentration of power creates a direct conflict between maximizing shareholder value and the public necessity of rapid, low-cost reduction of atmospheric greenhouse gas concentrations to prevent global catastrophes. A private cartel maximizes its profit by maintaining scarcity and keeping prices high, which directly contradicts the planetary goal of rapid, maximum volume carbon extraction to lower global warming trends. If the price of carbon removal remains high, only wealthy nations and elite corporations will be able to afford the carbon credits required to offset their ongoing industrial emissions. Follow the incentive structure. When the mechanism for planetary survival is privatized and concentrated, those who own the infrastructure gain leverage over entire sovereign states and international policy agendas. This leverage extends far beyond simple finance. It allows the cartel to influence environmental regulations, international climate agreements, and global trade policy negotiations to protect their own monopoly interests. Governments facing severe climate crises would become captured buyers of an essential service they cannot afford to stop purchasing from a consolidated private market with zero alternative supply options. Furthermore, the state cannot easily build public alternatives because the private cartel already owns the proprietary chemical formulas and critical mechanical engineering hardware patents required to run the plants. Additionally, these early entrants will secure exclusive long-term supply contracts for the massive amounts of clean electricity required to run their energy-intensive chemical separation and industrial compression processes. This preemptive capture of energy inputs prevents potential competitors from obtaining the electricity necessary to operate rival carbon capture facilities on a commercially viable scale in any domestic market. To test this economic hypothesis, we must consider how this market structure might behave under different scenarios, assumptions, and institutional policy designs that could disrupt the emerging monopoly. For example, if national governments bypass the private market entirely and construct state-owned carbon capture infrastructure, the commercial cartel model fails to emerge in that specific domestic jurisdiction. However, this public model shifts all capital risk onto the taxpayer, which many fiscally conservative governments are politically unwilling or unable to support under current budgetary conditions and constraints. Another exception occurs if a new technological breakthrough dramatically reduces upfront capital requirements, allowing modular, highly decentralized, and low-cost capture devices to be deployed by ordinary homeowners. If households and local businesses could capture carbon using cheap, standard equipment, the entry barriers would disappear, destroying the cartel's market pricing power and consolidating control over the atmosphere. Yet, current chemical engineering constraints suggest that process efficiency still heavily favors massive, centralized industrial complexes over small, decentralized domestic units due to thermodynamic scaling laws of gas separation. The policy trade-off remains: we must accept slow state-funded deployment, or invite efficient private capital that demands high monopoly rents in return for accelerating the deployment of extraction infrastructure. This conditional analysis indicates that relying on commercial market incentives does not guarantee the fastest or most equitable path to atmospheric carbon restoration or stabilization of global average temperatures. Instead, a profit-driven market structure is incentivized to optimize for value extraction, which often means maintaining scarcity rather than achieving maximum possible removal of greenhouse gases from the sky. Here is the constraint: when the basic mechanism of climate survival is outsourced to private markets, the providers will price it as a premium commodity, restricting access to wealthy buyers. The primary risk is not that carbon capture technology will fail to work, but that it will succeed under a highly concentrated corporate monopoly that holds the world hostage. We could end up replacing our historic dependence on fossil fuel cartels with a new, equally binding dependency on private carbon extraction syndicates that control the air we breathe. The very industrial conglomerates that built their capital during the emission era are now best positioned to control the market for cleanup, turning their liability into an asset. They possess the massive capital reserves, the chemical engineering expertise, and the political lobbying networks required to dominate this new environmental sector and exclude any potential public interest competitors. Change the assumption, change the equilibrium. If we manage carbon removal as a highly regulated public utility, we can limit these monopolistic practices and protect the global public interest. But if we leave deployment to open market forces, corporate consolidation and cartel pricing are the most predictable long-term economic outcomes for this critical and essential survival industry. This analytical framework helps us identify the true bottlenecks of the green transition, which are economic, institutional, and structural rather than purely engineering or technological challenges. When designing future international climate policy, we must look far past engineering feasibility and carefully plan the corporate ownership structure of the resulting carbon removal market. We must decide who will own the physical infrastructure assets that process the shared atmosphere that every living human being on Earth requires to survive daily. If we ignore market concentration, we risk allowing private entities to establish a permanent, high-priced corporate toll booth on the essential global carbon cycle itself. This analysis is not an argument against deploying carbon removal technology, but rather a necessary warning about the anti-competitive economic structure of its commercial deployment. Understanding these incentives allows policymakers to construct better public funding models and regulatory frameworks before the physical infrastructure is permanently locked in place globally. We must ultimately choose whether atmospheric restoration is managed as a public common trust or as a highly consolidated, private, profit-maximizing commercial monopoly system. The institutional design and policy choices we make today will define the structure of global resource allocation and climate governance for many generations to come. We must analyze who controls the physical mechanisms of global survival to understand where future power will reside. The future is just incentives at scale. See you tomorrow.